Hello, welcome. This is lesson 7.5 about symmetry and end behavior of graphs. We're going to talk a little bit about even and odd functions as well as symmetry. The function f is a function if f of negative x is equal to f of x. We'll explain that here a little bit in just a moment once we've done some examples. It means if you put in a negative value, let's say negative 2, into a function for x, and you evaluate it, you would get the same value if you put in f of 2. So we'll see that a little better here in just a moment. The function f is an even function if f is negative x or f of x is symmetric with respect to the y-axis. We know that symmetry refers to the idea that if I draw a line and were to fold that over onto itself, you would see the same image on the other side. It would fold onto itself. The function f is odd function if f of negative x is equal to the negative of f of x. So I put in a value, let's say f of 2, and then I get a value, let's say 3, and I make that negative 3. That would be the same thing as if I put in f of negative 2, I would also get negative 3. The function f is an odd function if f of negative x is equal to f of x is symmetric. F of negative x is equal to, this should say,
Thank you for calling Jeffrey Groups. This is Karina.
f of negative x, negative f of x. And this is symmetric with respect to the origin. And what that means is that if you were to reflect it over the y-axis and then reflect it back over the x-axis, you would get the same thing as you started with. So if we look at this first example where it's symmetric about the y-axis, we took f of x equals x squared plus 4. If we were to graph this, we know the x squared is a parabola, and the plus 4 moves it up 4. And so we can sort of see the symmetry there as we over the y-axis. But if we want to test it out, let's take the point 1, f of 1 equals 1 squared plus 4. And 1 squared is 1. 1 plus 4 equals 5. And then let's consider the other point, f of negative 1. We put negative 1 in and square it, plus 4. Well, negative 1 times negative 1 is still positive 1, and 1 plus 4 is 5. And because these are equal, because we have the point 1, 5 and negative 1, 5, then we say that this is an even function and that it's symmetric about the y-axis. Other examples of when you have symmetry about the y-axis would be like the x squared function that we just saw. Say x to the 4th, or absolute value of x would be also symmetric about the y-axis. Let's look at the next example that's symmetric about the origin. If you had f of x is equal to x to the 5th power plus x to the 3rd power, the graph of this looks roughly like this. And if we put in f of 1, we get 1 to the 5th power plus 1 to the 3rd power And 1 to the 5th power is 1. 1 to the 3rd power, 1 times 1 times 1 is also 1. So this equals 2. And so we have the point 1, comma 2. If I put in f of -1, then I get -1 to the 5th power plus -1 to the 3rd power, and this time -1 multiplied an odd number of times gives us -1, plus -1 to the 3rd power, same thing, it's multiplied an odd number of times, so you would get -1. -1 plus -1 would give us -2. And so we have the point -1, comma -2. And this is an example of what you would get. You have when you put in positive value for x, 1, you get 2 in this case. When I put in negative value, I get the negative of that, -2. And so this is an odd function, and it's said to be symmetric about the origin, which means that if I rotate this 180 degrees, it rotates onto itself. Or you can think of it as if I reflect it in the y-axis and then reflect it back on the x-axis, it reflects back onto itself. Then let's look at an example where there's no symmetry. If I put in for 2x plus 3, let's say f of 1. Oh, the graph of this, let's graph it. Go up 3 spaces here. And it looks something like that. So then if I put in 1 for x, I get f of 1 is equal to 2 times the x value, which is 1, plus 3. And that's equal to 2 times 1 is 2, plus 3, and so we get 5 is our y value. So we would get the point 1, comma 5. And then if I put in f of -1 to see here, if I put in f of -1, I get 2 times -1 plus 3, and 2 times -1 would be -2 plus 3, and that would give us 1. And so that'd be the point -1, comma 1. And this is a case where we have neither symmetry about the y-axis or about the origin. This is neither, so it has no symmetry. Let's look at some graphic examples. The y-axis. In this case, like if I think about this point, let's say this point 1, and it goes up, intersects our graph here at 2, so this point 1, comma 2, but if I go over to -1, I also go up 1, 2, and get to -2, and so this is an even function because it's symmetrical about the y-axis. If I look at the origin example, if I look at this point here, again, let's call it 1, and it goes up 1, 2, and we're at that point right there. If I go back to -1, and I go down -1, -2, I'm back at that point too. And so f of 1 gives us 2, and f of -1 gives us -2, and this is an example of an odd function that is symmetrical about the origin. And then with no symmetry one way or the other, if I look at this point, let's call it -1, and it goes up, we'll say 2, But if I go over here to positive 1, it's right here at the 0. And so f of 1 is 0 and f of negative 1 is 2. So there's no symmetry here, so this would be neither. Let's look at some other examples. Okay, so end behavior usually refers to whether or not the graph is going up or down. As the graph goes to negative infinity, we're going to call that, I'll use an L, that's left, as the graph moves to the left. And positive infinity, we'll call that R for right, what happens when the graph moves to the right. So let's see, if we were to take this example, 5x to the 5th plus 2x to the 4th plus x, and you might say, I'm not sure what that's going to do. I'm going to show you if we use a program called Desmos that you can get just on your browser. So if you open up a new tab on your Windows browser, you can type in Desmos.com, and it brings us to this window here, and we can say, okay, start graphing. Then in this little window up here to the left, after we've clicked start graphing, we can type in just the part to the right of the y equals. So I'm going to type in $5x, and then I want to raise it to the 5th power. So for that, I click on this little keyboard button that brings up this button down here, and I'm going to press this one that says A to the B, and that just raises it up, and so that I can then type in x to the 5th power. And then I hit plus 2x, and then I'd raise that to the 4th power. So again, hit this A to the B button and raise that to the 4th power, and then plus x. And over here, as we've been typing, different things have been changing on the graph. So we can get an idea of what this looks like. So to go back to our other screen. So here we know that it looks something like that. And so as we move to the left, or towards negative infinity, it goes down. So in y, we can say that it goes down towards negative infinity also. As we move towards the right, or towards positive infinity, we see that it's going up. And so we can also say that that's moving towards positive infinity, the y values. If we look at the next graph here, negative 5x to the 5th plus 2x to the 4th plus x. So it's very similar to the other problem. If I want to go back to my Desmos, I can graph that and just change the way that the graph looks by changing that plus 5x to the 5th and making it negative 5x to the 5th plus 2x to the 4th plus x, so the rest of it's the same. And so in this case, we see that it sort of does a little zigzag. So in our, back to our example, we can graph this. And it looks something like this. That goes down and this goes up. So this time, as we move to the left, or to negative infinity, it's going up, or to positive infinity. And as we move to the right, this is going down, or to negative infinity. And then if we look at another example here, 5x to the 6th plus 2x to the 4th plus x. If we want to go back and put that in Desmos, cancel the negative. We're going to change the little 5 to a 6. And then we've got 2x to the 4th plus x, so the rest of it's the same. But now we see the graph of this goes through the origin, dips down a little bit to the left, and then goes up to the right. So we can graph that. Make a quick little sketch, and it goes down something like this, and then up like this. So as we move to the left, or to negative infinity, it's going up, or to positive infinity. As we move to the right, or to positive infinity in x, the y values are going up also. And so up to positive infinity. And then finally, if we look at the other example here, got negative 5x to the 6th. If we look at Desmos, I put a negative in front of that. Looks like it's very similar to the other thing that we had, but it's flipped upside down. So we go back to our example, we can sketch this. It goes up sort of like that and then down. And so this, as we're going to the left, this is going down, or to negative infinity. And as we go to the right, this is also going down, or also to negative infinity. So when we say that end behavior is written in limit notation format, we're going to do the same thing that we did in those other 4 examples we just saw. But now we're going to write it in limit notation. So for left end behavior, that means we've got the limit as x approaches negative infinity of f of x, and that equals, and there we would put, if it was going up, we'd put positive infinity. If it was going down, we put negative infinity. Right end behavior, we have the limit of f of x as x approaches infinity, or positive infinity, and that equals, and then again it depends, if it's going up it'd be positive infinity, if it's going down it'd be negative infinity. So we look at these examples. The graph of negative 4x plus 3, I won't show doing this in Desmos, but you can. So it's going to look something like that. And so as we go to the left, because this is going up, we would say that's positive infinity. So we would write for the left limit here, we would say the limit as x approaches negative infinity of f of x of this function is positive infinity because it's going up. And then on the right, the limit of f of x as x approaches positive infinity, because it's going down, we would say that it's going down towards negative infinity as it approaches the right, as it goes to the right. And so as it approaches positive infinity, the limit is negative infinity because it's going down. If we look at the next example, this is a parabola that's facing down. And we would say, so here as it's going to the left, it's going down. And so it's approaching negative infinity. And it's doing that also as it approaches on the right. As we move to the right, it's going down or also towards negative infinity. And so our left limit here, we would say the limit as x approaches negative infinity of f of x equals negative infinity because it's going down. And then our right, the limit of f of x as x approaches positive infinity is equal to also negative infinity because it's going down on both sides. We'll skip this last example just because it's a little bit unique and I don't think it's really important. If we were in person, I would explain it to you. And then if any of you want to have it explained to me, just reach out to me. Now go ahead and practice on your own, do the homework problems, and good luck.